Okay. So there it is. All right, there it is. Okay. I'll turn it off right now. Okay. Yeah. I won't. You wait. Okay. I think it's about time. Got a few people walking in. Okay. It is 2:45. I think I can start and get us talking about specifications. So, my name is James Corney. I work in the structures division. I am the structures construction engineer, and I've taken over the standards and specifications for the structures division. Turns out that I really like standards and specs, so I am presenting on behalf of specifications in general today. I hope you like what you hear, because specs are fantastic. The plans get all the glamour, but the specs have a lot of power and are vitally important, so I'm glad you all came today. You've got a whole hour with me, so I hope you're prepared. I plan on breaking this presentation up into two parts. Here's the outline. I'm going to start with a general discussion about what specifications are and how they fit into the greater world of the contract, and then move into the writing itself. It's incredibly exciting, as you can tell by my visual gag with part 1 and part 2. You get it, eh? It's hilarious. But that's the level of joke you're getting for this hour, so buckle up, everybody. Let's start at the beginning. What are specs? Specifications are just one part of a contract, which is made up of a bunch of pieces which all need to work together. Pieces like plans and specifications, or as the standard specification states it, specifications and plans. Then there are the minimum sampling and testing requirements, or MS and TR, the measurement and payment, or M&P, and other important operation documents like the bidding schedule, notice of award, change orders, and other things that are not quite in the focus of the presentation I have for you today. At the design level, we're focused on these things, and specifications are just one part, or should I say, just one role. So, taking the role aspect to make these concepts more relatable, let's personify these things. The measurement and payment is the accountant signing the checks. The MS and TR is the quality control manager, making sure that the work performed is good. Plans are like an architect. They tend to focus on the end product and not about what it takes to get there. I didn't have a great architect clip art, but this guy embodies architect to me. I bet he has nice shoes too. And the specifications are the engineer, focused on taking an ideal end result and finding a way to make it work. And altogether, these roles communicate with the contract or contractor, who turns ideas into reality. The specs aren't fancy, but like any good engineer knows, what we do needs to work. It needs to calc out. And that is truly appropriate when we're talking about the specifications. But please realize, without these individuals working together, the project will not work properly. You need to know what you're building, you need to know that it's going to work, and that it's going to be built correctly and paid for. Each member of the team has their domain, and in order to properly coordinate with each other, we need to respect their boundaries and expertise. The specifications and the plans are usually described in the same breath, specifications and plans, because they work so closely together to show the final condition, asterisk, and define the work that needs to be performed to achieve that final condition. The asterisk is just there to mention that the plans do need to be constructible and may require showing construction options. It belongs in the specifications, but as a general rule, if the described thing is related to the construction process, it belongs in the specifications. And if it's a description of what you want the constructed thing to be, it should be shown in the plans. I'll focus on these contrasts as we continue through this presentation. The minimum sampling and testing establishes the testing requirements for products installed in the work and determines if those products are good enough to be paid for. And of course, the measurement and payment describes how the work is measured and paid. Design engineers are often very focused on the plans and can forget the roles of the specifications, MS and TR, and M&P. In fact, I think the MSTR is something so obscure to the design engineer that they don't know what it is. And because specifications are so complex, they would rather shove work requirements into the M&P instead of the specs, something that technically doesn't work and could become a legal problem. At this point, I've spoken about work as if everyone knows what it is, and hopefully you all actually do, but since this is the specs we're talking about, I want to get specific and show exactly what is specified in the specifications. Work is defined in the general specifications, section 570, article 1.7, subparagraph A96, as, quote, the elements, activities, and incidentals necessary to complete a project, including labor, materials, equipment, and the interim products and stages attained in the course of reaching completion, and all alterations, amendments, or extensions made by change order or other written orders of the engineer. That's a lot of words, but I wanted to show the legal definition and reinforce what you all probably assumed, that we're talking about the stuff that makes the project, the physical things, the action to use and place those things, and anything else that might be necessary in the process of creating that thing that is shown in the plans. At this point, I've spent the last few slides talking about these different roles, and I've tried to make it cute and understandable in a simple way. But why is this important? Because ultimately, we're not dealing with people. We're dealing with robots. People can read between the lines and share responsibility and make mistakes and laugh. Robots don't laugh. If we place an item of work in the M&P instead of the specifications, and that item either isn't paid for or isn't constructed correctly, then no one is laughing, except maybe the lawyers, because the contract is a legal document. Mistakes and inconsistencies, if they're involved in major problems, result in legal scrutiny. It's not just a matter of saying the contractor will understand, because although that is true 99.9% of the time, it's that 0.1% that we design for. So, now let's move away from our characters and talk about money. After all, money makes the world go round, and you get what you pay for, and we pay for what we get. For the contract, that means pay items, firmly under the ownership of measurement and payment. The pay items identify what things we are paying for. And I use the word things here on purpose. We're talking about items or tasks. For example, we could have an item for tree pruning. What do you think would be involved in that work? If you're thinking pruning trees, you're only partially correct. The pay item is not intended to specify all of the work that needs to be done. It connects to the measurement and payment and the specification, which provide more information. The M&P provides information on measurement and payment, and in this case, the M&P is completely blank for this pay item, which is totally fine and extremely normal. The work for this item is specified in the specifications and includes pruning, disinfecting equipment, and disposal of branches, along with other specific minutiae about what the expectations are for that work to be performed correctly. So here's the hypothetical. What if at this site we wanted the branches mulched and placed at the base of the trees? Where would that information go? Yeah, you guessed it. This is the Specifications 101 session. It goes in the specification because that is work to be performed. This connection to the specifications is made through the 9-digit pay item number. The first 5 digits are the related specification, a direct link to the work requirements for that pay item. The following digit, the 7, was added after the major specification revision UDOT enacted in 2017. And the final 3 digits represent the individual pay item within the referenced specification. For tree pruning, there's only 1 pay item. That is often not the case. Multiple pay items can direct to the same specification. This is pretty obvious for something like drainage pipe, which has something like 50 variations in size of pipe. But it also applies to work, like remove structure and obstruction, where the name of each pay item engages just a portion of the specification. For example, 022217080, remove fence, only engages Article 3.22 and any relevant connected portions of that spec. It does not engage Article 323, remove tree, because that's a separate pay item, 022217050, remove tree. So what I'm trying to say here is that the specification describes the work to be performed and is engaged by the simple name of the pay item, of which there may be multiple for a single specification. It's appropriate to do that, but the connection needs to be clear. But this also means that additions of work to existing specifications can be unclear. In the tree pruning example from the previous slide, if the mulching was simply added as a new article to the specification, it could be unclear that this was work intended to be incorporated into the tree pruning pay item. This can be solved by adding a mulching pay item, or by clarifying in the specification that mulching is part of the pruning work. This is often done through the section includes description. I'm sure that this could be wordsmithed better than what you see on the screen, but I think it gets the point across. Pay items rely on the specification to define the work that is to be performed in the project. But that's just tree pruning. For a project, we need a lot of pay items because every piece of the work needs to be paid for, and for it to be paid, there needs to be a pay item. And if you want that mulching done, it better be clearly included. And making sure that it is included is part of why spec writing is so important. We need to be diligent. I've been using the term pay item here instead of bid item because I like the direct link to payment and how serious a topic that is. They are essentially the same thing, except that the bid happens before contract award and pay happens after. I take this moment to bring that up because a job is awarded based on a bid, and that bid is based on bid items or pay items. Things may be shown in the plans, but unless they are tied to bid items, they are not included in the contract amount, which is defined as the summation of the products of the quantities shown in the bid schedule multiplied by the unit bid prices for the items in the contractor's bid proposal. This is it, folks. This is why the specifications are so very important. If the work that we want is not specified and included in the bid items, it's not included in the project, even if it's drawn on the plans or written in the M&P. Each subdivided work item must be clearly defined. Every work activity must be paid for. Every product, every material must be purchased. Every piece of equipment that we expect to see. Specifications are important, and that's the purpose of this first portion of the presentation. I'm trying to impress you all with that understanding. Plans are great and super specific to the project and calculations that designers spend so much time on, but the specifications require your time and respect too, because that pretty plan doesn't get built unless the specifications say to do it. Okay, now that you're all fully on board and as passionate about the need for good specs as I am, let's move on to spec writing. Nah, I still don't think we're there yet. How about we get introduced to UDOT specs first? The UDOT standard specifications are split into two ranges. There are the general specifications, which have section numbers less than 1,500, and the technical specifications, which have section numbers at 1,500 or greater. This is an important nuance for UDOT's specifications, and something that was introduced back in 2017. But what are they? Well, the general specifications apply to and govern the work of all sections of the specifications. That's from section 100, subparagraphs 1.7a to a. So when you're all writing your technical specification, remember that all the stuff in the generals applies without reference. Like what, you say? How about not needing to say, allow inspectors to inspect, or correct defects, since that's already in 727 control of work, or not needing to say, allow the department 14 calendar days to review, since that's in 1450, submittals. The general specifications provide a lot of information for the proper administration of the contract. And if you ever find yourself writing a reference back to those low-numbered specifications, stop. Those sections are already engaged, and making the reference anyway is detrimental, as it begs the question, are the non-reference sections still applicable to this spec? Technically, yes, but we don't want the confusion. Now, I read the quote from section 100 here. I highly recommend that everyone who is going to do any spec writing reads section 100 general provisions. That one 7-page section defines a lot of very fundamental information for the contract and spec writing. I will continue to make reference to section 100 as I continue through this presentation, but I really don't want to just read 7 pages of text to you. So please take some time and make that relatively quick read. Another thing to think about is the nature of standard specifications. Unlike plans, which are made uniquely for each project, standard specifications stick around. This ties back to our previous discussion on pay items. The pay item activates the specification. This means we can have hundreds of possible work tasks detailed out in the specifications, but only the ones with pay items actually activate. This is a caution to you to think about how the specifications you write are going to fit into the larger standard, and not think about the specification as some simple extension of the project you have. Do not oversimplify writing your specification to add unique aspects of the work that are not clearly engaged through a pay item and shown in the plans, assuming that it's part of the final construction. I can hear the eye rolls saying, but I'm not writing standard specifications, I'm writing special provisions. And while yes, that is true, special provisions are not necessarily going to stick around from project to project. That doesn't mean that we should reformat how specifications work or should be thought of as a simple sidelined task. Just writing project-specific language and saying, do this into the special provision does not mean that it is automatically engaged if the pay item wasn't properly connected. It's also important to think about how serious those special provisions are to the project. Here is paragraph 110B from section 727, control of work. As you can see, special provisions are the highest priority contract item for the purpose of conveying information to a project. Lack of attention here can be impactful. Not only that, though, but we always want to think about progressing our special provisions toward standard. At the early stages of special provision, that may seem like a faraway, long-term goal, but special provisions tend to act as draft versions for future special provisions. And if we can keep our eyes on the goal of moving towards standard, we should be able to improve the quality of our specifications use after use until they can become incorporated into an official standard. Sorry, I slipped back into talking about how important specs are again. But it's true. And now that you know how beautiful UDOT specs are on the inside, I think it's fair to show off how beautiful they are on the outside. Here we have some specifications that are reasonably representative of what you would see anywhere in the country. This particular few pages is for reinforcing steel. And here, you see a few pages from UDOT's reinforcing steel and welded wire specification. Pulling up just one page from each, showing the presentation, you can see that there's a major difference with the formats of these sheets. It's the sheer amount of text on the page. I'm not saying that UDOT specifications don't have as much information in them as other specifications, but the information provided is easier to read and understand. You might end up with just 20 pages in a spec, but by using an outline format instead of a paragraph format, the information you're looking for stands out more readily. To summarize this point, when you're writing UDOT specifications, every line should be a single sentence or phrase, and you need to consider if the point being made is a new concept or a subtopic to the previous one. This allows for an instant understanding when reading a UDOT specification that one point is related to another. In this case, these sleeves are related to a condition of insufficient space to maintain clearance between stainless steel and other steel in which it might come in contact. This is a major clarity benefit, but it has risks as well, as moving a line into or out of a parent heading can completely change its relevance to the specification. I'll bring up this point again later, but think about the advantage this outline format has over paragraph formats. As the paragraph format, there's only one major heading per article. So establishing relation and priority is a challenge. With that, let's move on to the parts. Similar to how the specification book has two ranges, one for general and one for technical, each specification has three parts. Part 1 is general and is mainly administrative? Anyway, a better word for this might be paperworky. And it's broken into 5 required articles. These articles will show up in this order in every specification so that we have consistency, and it's easy to read. It's serious enough that if there isn't any content for these articles, we write "not used" after the header so that we maintain this sequence. I'll get into what each of these 5 articles are for, but I also want to mention that you aren't limited to these 5. As the spec writer, you can add as many articles here as you need, so as long as they focus is on administrative, process, paperworky things, like quality assurance requirements, acceptance, qualifications, design requirements, that sort of thing. So let's go through these articles one at a time. 1.1, section includes. This is the very first piece of unique information within a specification, and it is supposed to provide a quick grasp of what a spec is about. I've already spoken about the connection between the section includes article and the pay items and how important that is, and ultimately that is what this is about. You don't need to get too wordy here, as none of the content here is intended to direct the work. What this does is provide a descriptive link between the specification and the pay item, and introduce the content of the specification to the reader. Deck drain pipe extension. Sounds really simple, and it's supposed to be. It's a quick snapshot that shows what the spec's about. Any content in the specification that is relevant to deck drain pipe extension is going to be incorporated into that pay item. And the deck drain closure information isn't. Next up, let's talk about related sections. This one is super important. The specifications are not independent documents. The book works together as an interconnected whole. This allows us to say things once and in the most logical location. When we make a reference to another section, what we're actually doing is incorporating all of the relevant information and requirements from that specification into this one, or more accurately, into this pay item. In this example, Article 2.5 specifies Class AA LS concrete and then refers back to Section 3055. Any reference in the specification must have a corresponding paragraph in 1.2 related sections. This is the summary, which shows how interconnected a specification is. Having this reference then means that all of the requirements in Section 3055 related to Class AA LS concrete are included in the cost of this pay item. To provide a little more context to this concept, realize that Section 3055 Portland cement concrete doesn't even have a related pay item. The only way the requirements of 3055 are engaged and the work associated with it is paid for is through the related specifications. So thinking about how super important this is, that means that even if referencing another section would provide nice background for a task covered by this pay item, don't make that official reference. You can talk about things with words, like place new frame riser before placing asphalt surfacing, but do not make the direct reference unless you intend to have the entirety of the referenced specification paid for under this pay item. Next up, 1.3 references. I wanted to make the joke that everything is super important, but I just can't get my excitement up for specifications to that point. The references are simply an index to any external document mentioned in the specification. It can be nice to have an upfront collection of referenced documents, but even I have to admit that this is slightly paperworky. That being said, it's a lovely collection of the references used by the spec and can give a heads up that the spec will contain welding requirements or design considerations. And yes, I have made a note that my references in the spec are not in alphabetical order. Perfection is the enemy of progress. We'll get that fixed. Like all of the specs and special provisions, we need to be aware of the desire for forward progress and getting better and better standards. 1.4, definitions. This article is rarely used, but it can be quite useful in certain situations. It's rarely used in part because the specifications already have an entire definitions section, which, because the section number is less than 1,500, means that it applies to all specifications. But it's also rarely used because it's simply not that often we need to define terms. But sometimes we do, and when we do, it's important to understand the limitations of Article 1.4. Merriam-Webster defines the definition of definition as a statement expressing the essential nature of something. That is to say here, in Article 1.4, when you're providing a definition, you're just expressing the essential nature of the term when it's used elsewhere. You're not exactly providing work requirements. There's a bit of interpretation here, as this provides the essential nature of a term which is used in specifying requirements. But please try to avoid placing technical work requirements in 1.4 instead of a more relevant part of the specification. The definitions should focus more on clarity than requirements. In this example, providing a specified maximum water-cement ratio in the definition would not be appropriate. That limitation should be shown in Part 2. Okay, 1.5, submittals. Back to super important. This is where we list everything that needs to be delivered to the engineer, either looking for the engineer's input or for the engineer to record. Anytime the specification indicates that the engineer needs to be contacted for any reason, there needs to be some sort of submittal included. Section 1.5 is where the RE turns in order to know what communication is needed for a spec. Now, this is one of those places I mentioned earlier as having a strong connection to the general specifications, specifically Section 1450, submittals. It provides a general, universally applicable information on how submittals are submitted. For example, drawings should be on 11 by 17 sheets submitted as PDFs, and a professional engineering seal is required for calculations and drawings based on calculations. It also provides 3 major categories for submittals: submittals for approval, submittals for review, and submittals for information. This is a topic that confuses a lot of people, so I hope that we can get this idea across to you all here. But know that if tomorrow you forgot what I said here, this information is in the general specifications. So let's start from the top. Submittals for approval. When you say for approval on a submittal in your technical specification, like permission to shoot varmints with a BB gun for approval, it automatically engages general specification 1450, where submittals for approval requirements are specified. Here, we can see that submittals for approval provide 14 calendar days for department review. So unless you want to change the review period duration, saying nothing more than for approval will get the department 14 calendar days. Section 1450 also says that work cannot proceed until approval is received and gives the department the authority to rescind approval if warranted. These statements that I've highlighted are things that designers tend to like to add to specifications because they are important. But now you know that these things are so important that you don't need to add them. They're already written down. But now that I've shown you how easy it is to require a submittal for approval, I want to follow up by saying, don't require submittals for approval. Require them for review. Why? It's technical. Submittals for approval can be approved, and submittals for review can be authorized. I'll get to submittals for information later. Now, these two terms have specific definitions in 570 definitions. I'll start with the review/authorize definition. If something has been authorized, it has received, quote, formal conditional determination by the engineer that a particular matter or item designed or produced by others may be used. Such determination may be based on reasonable and accepted engineering principles typical for the work produced. Authorization does not relieve the contractor from responsibility for negligent acts, errors, correctness of details, conformance to the contract, and the successful completion of the work. I assume that was super clear to you, and you all got the nuance from that quick reading, but to justify my time up here, I'm going to simplify. When something is authorized, the engineer gives permission for the submittal to be used and for work to proceed. And this permission is based on the content and quality of the contractor's submittal and a reasonable engineering review. And in the end, we all understand that the submittal was developed by the contractor and reviewed for contract conformance. In general, this is what I think we all expect from an engineering review. The problem is that in the English language, we like to say that the RE generally approves of our decisions, but approval is a very different thing. Approval is, quote, the formal conditional determination by the engineer that a particular matter or item is satisfactory for the project. Such determination may be based on requirements beyond those set forth in the contract and may reflect preferences by the department. Items approved are considered to be as if part of department design. This one is more plainly written than authorization, but I'll use different words again anyway. What makes approval so wrong for most decisions is that here the engineer makes unilateral decisions that don't need to meet any pre-existing conditions of the contract. And they don't even need a basis for that decision aside from preference. In the end, because it's not based on the existing contract, the approval process is what incorporates it into the contract and makes it a department design decision instead of a contractor proposed solution. So permission to shoot varmints with a BB gun? Yeah, that's probably an approval thing because that's not going to be in the standard contract. And we'll definitely say no, regardless of the preference of the engineer. But plan for the relocation of migratory varmint nests during the specified relocation window? That would be for review. Okay, and finally we have for information. Submittals for information are probably about what you'd expect them to be. They're very simple. There's no time component for a formal review, and there's no waiting for authorization before work can proceed. But the submittal is supposed to be provided to the engineer before incorporating into the project. I'll say when possible here, since we sometimes have submittals for records that would only occur after the work has been performed. But an important point for information submittals is that, like all project submittals, once it's given to the engineer, it will be looked at for general compliance. If it's not conforming to the contract, the engineer can require repair or replacement or whatever is necessary for contract conformance. But usually we hold for information submittals to those elements that we feel confident will not cause a contract conformance issue. One final comment on submittals. Remember, part 1 is all about paperwork. So the submittals being in part 1 are the paperwork requirements of a submittal. What do you want to see submitted? For example, here's a shotcrete mix design and test result submittal. Now, it's not really the point of this slide, but it is for approval here because the department approves mixed designs based on performance in trial batches. It's kind of a unique situation. Anyway, the actual point here is that there is a pre-construction test panel that must provide information for the mixed design to be approved. The paperwork requirements of that test are included here in part 1. But the actual in-the-field action of the test itself is in part 3, execution. In these situations where some sort of action in the field is tied to a submittal, it can be very easy to overlook the fact that the requirements for what seems like a single event need to be broken into 2 places. The paperwork goes in part 1, and the action goes in part 3. Well, those were the required articles of part 1. Remember, you can add other articles to part 1 as needed. Just remember that part 1 is for the administrative, process-oriented, paperworky things that are required to properly complete the work for your pay item. It feels like I've gotten a bit past the getting to know you stage of the specs, and hopefully you've all been entranced by how complex and deep UDOT specifications are and are ready to move on to part 2, products. At this point, we're moving away from paperwork, and we're looking at the things that are going to be used on a project site. This can be anything from dry cement powder to expansion joints to a fully cured precast prestressed concrete girder. If it's a thing that is used on a site, it's a product. It's not that complex as a concept, but where the products can get complicated is in understanding that the specified requirements for products needs to be non-proprietary and generally performance-based. What does that mean? Well, if you're trying to specify something proprietary, you would specify brand names, model numbers, or something that would identify a product as uniquely from a single source. This is prescriptive and restrictive, words that we don't like. Instead, we want performance-based specifications. This describes the required results and criteria by which performance will be verified. This is non-restrictive by nature and opens the market for competition. So let's look more specifically at how to set a performance-based specification. It's probably simpler than you think, but maybe not as flexible as you'd like. Here is the specified requirement for cement from section 3055. The spec says to use type 2 or equivalent and then points to table 4. Table 4 then provides AASHTO and ASTM specifications for the equivalent products. Boom, performance-based spec. What, you ask? Didn't we just specify the exact type of material here? Sure, we gave equivalent options, but that sure looks prescriptive. Well, let's think about what a performance requirement is again. It describes the required results and criteria by which performance will be verified. What are these AASHTO M specs and ASTM specs? Well, it's in the name, sort of. ASTM, formerly known as the American Society for Testing and Materials, provides standards by which materials are tested. Let's look at ASTM C595 for blended cements. In order to meet the requirements of the specification, it needs to be a type 2 equivalent The cement must meet the requirements of ASTM C595 for IP-MS material. IP materials have certain chemical requirements and certain tested physical requirements, but for simplicity, what I'm showing on the screen are the MS requirements, which are physical tested criteria which establish a product as meeting the performance requirements of an MS material. Now, because of the very specific chemical requirements, I do acknowledge that I am towing the line on what a performance-based spec is here by showing the Portland cement concrete. Actually, this is C595, the cement. But most ASTMs are not so restrictive. So let's look at an expansion joint instead. That sort of product will be much more common to the development of specifications. This is from section 5831, compression joint seal, and provides the performance requirements for a compression joint seal type A. The requirements are that the product meets certain baseline minimums and provides ASTM criteria where applicable. It is then up to the manufacturer of the product to meet the performance requirements stated in the specification. But how do we set these numbers? In general, you're going to want to look at what products are on the market. Take a look at multiple product technical data sheets, and then use experience and engineering judgment to determine what properties are appropriate and commonly presented on those sheets. Please realize that it is very difficult for product suppliers to provide specific testing for one DOT. So if you want to supply a performance-based criteria for a property that isn't commonly published, we are unlikely to get it. The manufacturer might lose money getting the test versus just not getting the job. For completeness, I was thinking about showing what we have in section 3412, pre-stressed concrete for precast pre-stressed girders, but it's actually very similar to what you would see in part 3 for execution, except that it's in part 2 because all of that work is performed in a fabrication facility, and the final product shipped to the site for use by the contractor on site. So I'm going to spare you that content and simply move on to part 3. I don't think it would be too outlandish to say that all the work that is done in parts 1 and 2 are built up for part 3. Part 3 is the execution part. This is the work on site, and this is likely where you will spend the most of your time and focus when writing a specification. But it's also the part which probably feels the most natural as you think about how you would like to see the pay item prepared, constructed, and protected. As engineers, we have an innate talent for understanding our physical world. So, in general, writing specifications is something we are fully capable of. This is why I wanted to spend so much time in this session talking about parts 1 and 2, because that's the paperwork stuff and the off-site stuff, and I don't think we're as comfortable writing toward it. It's very appropriate, when writing your specifications, to start with part 3 and focus on the work that needs to get done. And then, when you hit something that sounds like paperwork or a submittal, jump back to part 1. Make sure it's connected. Or when you have a product, jump back to part 2 and get the details written in. Remember, parts 1 and 2 support and feed part 3. So remember to jump back to those sections and make sure that they are adequately developed for the execution to go smoothly. Now, I bet you expected me to spend a lot of time on part 3, since I spent so much time on parts 1 and 2, but the truth is that there really isn't much I can direct you on when it comes to execution. There are so many possibilities to address the specific needs or challenges or whatever specific pay item you're writing toward. In the following discussion, I am going to focus on the nuance of writing to the UDOT style and provide some instruction on things to keep in mind and the difference between picking one word over a different word. But when it comes to execution, there's no set path except to try to keep things clear, concise, correct, complete, and consistent. And awake. I love fractals, but they freak my wife out. Anyway, now let's move away from the general and maybe not so general description of the specification, and move to the words on the page specification writing. If you wouldn't mind taking out a smartphone or some other smart device to try to grab this QR code, this will take you into a link to grab a handout that was developed providing recommendations for spec writing. I will be talking about it as we go forward, and that QR code will be shown on every subsequent slide, so I will try to keep things rolling there. So if you have that, let's start with the general things at the top of page 1. Consistency is important. It may seem like a lot of specification writing is rules for the sake of rules, but that's not the case. We're trying to maintain consistency and usefulness of the specs. Being consistent allows for easier reading and understanding of the specifications as a whole. I could say, your selection of the lexicon placed in the charter that is this regulatory document may exemplify your erudite perspicacity, but should rather be selected for their pedantic generality, or use simple, consistent language in the specification. Sometimes that means that we pick the words for you, but that's because those words have meaning, and we want to be consistent. And yes, the work involved in writing a consistent specification can be a little annoying. But you really shouldn't justify weak writing by thinking the RE has the authority to do whatever they want. While that might be true, what that's doing is building a culture where the specifications don't matter until there's a need for dispute resolution. And then it's too late and everyone's upset. And this is usually based on the misconception that the RE will always bend the rules or fill in the gap in the way that the designer approves of. You simply can't assume that. And finally, for the general recommendations, I've said it before, but it's worth repeating, the specifications are written to the contractor. Do not use specifications to speak directly to subcontractors, the RE, inspectors, or others. Now let's move on to the style category. As I said before, UDOT specs should be written with one sentence or phrase per line. It might seem awkward at first, but it really helps to organize the content for clarity and easy understanding. Make sure you think about what goes under a header, if it's related information under a topic, or if it's of equivalent importance. Remember, information that is placed under a header is not applicable to a different header of equivalent priority. Each of those lines should also be written with active voice. That generally means that you should try to start out each line with a verb, like prepare, give, provide, sign. It's not a hard and fast rule, but the point is to be direct and clear in your communication and set expectations. We do not want to use the word shall either, for this is not a strong and direct word. Next up, common words. We recommend that you use the term calendar days instead of working days. In section 570 definitions, we have a specific definition for working days. Any calendar day, except holidays, or days restricted in the contract. Remember who the specifications are written to. They're written to the contractor. It can be very easy when writing a spec to think of the number of working days for a government employee. And if you would like to sign a petition to try to get Halloween off for government employees, I'm all for it. But the working days here are the contract working days for the contractor, who may work any day except those which are restricted by the contract. It's much easier to think in terms of calendar days. Then there's new and existing. In general, try to avoid these words unless there's a specific situation where you need to make a distinction between what is new and what is existing. What is being placed or installed is likely new, and that's already understood. And we don't need to describe the new pothole patch in an existing header next to an existing expansion joint. Okay, now, if you're following along your handouts, I'm going to jump to the third page to talk more about style choices and specific words and symbols. The next one I want to talk about is ensure. It's similar to shall, but ensure isn't a word that provides strong direction. It does provide strong expectation, though, which can be very difficult for contract enforcement. Rather than using ensure, use words that connect direction to action, like verify or monitor. On your handout, I called this the search and resolve section, because finding these naughty words is easy, but it isn't as simple as pasting a direct replacement. You will often need to rethink how you're going to ask for what you need. Another style word is in the plans. I recommend searching for these words because it's usually in the phrase as shown in the plans. But the term shown is a good word and has already been defined in section 100, where shown means shown in the plans. So repeating that phrase is unnecessary. Additionally, although less commonly used, specified means specified in the specifications, and described means described in the contract. You might end up using those, so I want you to be aware that those definitions exist, but shown really is the most commonly used of those three. Continuing down the list, we have a few simple language words. Prior to, maximum, and minimum. These are minor word choice changes that are intended to make the specification sound more like plain speaking. Instead of prior to, we want to say before. And instead of maximum and minimum, we want to use no more than or no less than. Please note that max and min can and should still be used in data tables. Now, all I can say for these is that it is a UDOT style choice. Personally, I haven't had issues with the understanding of these words, but my perspicacity is such that I like words like prior to and heretofore. Regardless, to make the various specifications in a standard book sound like they're all written by a single entity, UDOT, we have these word choices for you. Then there are the units. The UDOT style is to associate certain styles of unit with numbers. So if you want to say 6 inches, you would actually write 6 inch. The reason seems to be that we just didn't want to abbreviate inches to in, since in is its own English word. And finally, last style choice, we prefer not to use the words any or all. In general, these words simply aren't necessary and don't add clarity. So UDOT style is to not include them unless they do add meaning. I did try, but it can be difficult to justify style choices. But in the end, this is what it is, style. And we want a consistent style in our specifications. Next, however, I'm going to move on to items of substance. This is the page 2 part of your handout, and a lot of this we've already spoken about. We spoke about how pay items are linked to specifications and how we should only add references to other sections if the referenced work is included in the pay item. And when you do make that reference to incorporate the work for that specification, make sure the words you've used match the name of the work in the other specification. This is best when there is an actual article title you can reference. We've also spoken about submittal types. If I didn't mention it before, please remember to assign a submittal type to all of your submittals in Article 1.5. Without an assigned type, the contractor won't know what they're responsible to do and what the timing of that submittal is. And remember, the content in Article 1.5 is for the paperwork submittal. There may be other tasks associated with the submittal, whether it's determining the qualifications of an individual or performing quality control at a fabrication site or determining the need for varmint control at a site. The non-paperwork information associated with the submittal needs to be housed in separate articles in parts 1, 2, or 3 as appropriate. Now let's talk about some things to avoid. Avoid saying unless shown otherwise, unless you are sure that there are alternatives that are regularly shown. What we're trying to avoid here is the expectation that there is some commonly approved alternate procedure floating around somewhere. This can lead to confusion if the common expectation is to simply meet the written specification. Please remember that deviation requests are a viable method to alter contract requirements. Adding an unless shown otherwise type statement can open the door to providing an alternative without requiring a deviation, but you need to think about whether or not lowering that barrier is necessary or even a good thing. Next one to avoid is using as directed by the engineer. Instead, you should use as determined by the engineer. There's a subtle but very important difference here. Directed is a term that indicates that the engineer is providing a new requirement that is outside of the current contract requirements. This can lead to a change order. Determined, on the other hand, simply means that the engineer is making a decision within the limits of the contract and supplying required information to proceed. So do not use direction unless, again, you mean it. And then how about this for a final specific requirement? Avoid setting temperature limitations, including and rising or and falling. This has been a pretty common shorthand for wanting to make sure that temperatures are acceptable for certain types of work. But although having a temperature above freezing and rising seems like it makes sense, it's because the mental image here presumes that we're just transitioning out of a freezing condition and then rising. The literal robot wording on the page says that the temperature must be rising. So a nice summer afternoon, totally fine for the work, but doesn't meet the specs because the temperature is 90 degrees and falling. Rather than using this language, speak to the anticipated duration above the required temperature. Say something like, temperature above freezing for at least 8 hours after beginning placement. Something like that. Anyway, that's what I had for you. We do have that QR code if you do want to grab the link to that helpful resource. And if you have any questions, my name is James Corney, and you can email me at jcorney@utah.gov if you have any questions, and I think that's about it. So, thank you. Oh, we have a question. Sorry.
For project-specific sequencing requirements, is it acceptable to write requirements as notes in the drawing, or do you recommend always using special provisions?
For project-specific sequencing requirements, is it better to show it in the plans or the specs? So that is one of those situations where showing things in the plans because of the visual aspect of it can be helpful, but it really depends on the exact need that you have. The specs showing work process is the appropriate place for that sort of thing. So if you want to see the work process followed in a very specific order because it's required for quality control, the spec would be the more appropriate place for it. Pairing that with the drawing might be a good idea, though. Any other questions? Okay. Thank you very much. Okay. I never did get the QR code or the document from Amalia, so I whipped that up with the little rubber ducky. Oh, I'm sorry.